And the first for the last of the afternoon session is Professor Don Huber. Don comes to us from Idaho, and where he now lives in retirement. He is a professor emeritus at Purdue University. He has over 50 years of research, scientific research in his career, and 40 years he has spent on the Threat Pathogens Committee, a joint committee of the U.S. Department of Defense and U.S. Department of Agriculture. Join me in welcoming Don.
Thanks, Jack. Well, it's an honor to be here. I thank Claire and the organizers of the program here that make it possible for my wife of almost 56 years now to visit here. But we appreciate that opportunity you've provided, but it's really my wife and 11 children that make it necessary. So have a woman that had lost her husband about 12 years earlier and became very lonely. And her children noticed this and said, "Mom, you need a pet to kind of keep you company and give you something to do, something to share your feelings with." And so she took that counsel to heart, went over to the pet store and explained her situation to the pet store owner, grabbed her by the arm, and he took her back to the back of the store and showed her this beautiful Brazilian parrot and said, "This guy's just exactly what you want. He'll talk your leg off." Said he'll keep you company. Said it's just perfect for your needs. She bought the parrot, took him home, came back the next day and said, "Well, he hasn't said anything to me." And the pet store owner said, "Parrots like to exercise when they talk, kind of like retired professors. We have to have a captive audience sometimes." But so said they like to exercise and move around, and said, "You have some stairs." So she bought the stairs, took them home, came back the next day and said, "He still hasn't said anything to me." So the pet store owner said, "Well, do you have a swing?" So she bought the swing, took it home, came back the third day and said, "He still hasn't said anything." Said, "What am I doing wrong?" Pet store owner said, "Well, parrots have a high vanity quotient. You have a mirror." So that she bought the mirror and took it home. And the fourth day, she came back with a dead parrot and said, "He hardly said anything to me before he just keeled over and died." The pet store owner said, "Well, what did he say?" She said, "Well, I'm not quite sure, but it sounded like something like, 'Doesn't that store sell any food?'" Well, we can easily get enamored by all the pictures in the magazines and the PR of how we have to move to the modern approaches and the scientific approaches of how to do everything, and forget that when we're farming, we're really managing an ecology, as you've heard here from Jack and from Bob, from others. And it's that ecology that we're managing that's going to determine the nutrient density, the yield, the disease susceptibility, and all of the other aspects that we're growing those crops for are dependent on how we manage that ecology. All of that ecology is based on the abiotic environment, the chemical and physical characteristics, but we have a very dynamic biological environment that we sometimes overlook. When you step on an acre of soil, you're stepping on anywhere from 10 to 20 ton of living matter. Now, in that ecology, we also have the stress and the pathogens and pests that are involved in that area. And you have the plant that's constantly changing the environment through root exudates and its own nutrient needs. But it's the interaction of all of these factors that determine the quality of that product that we're producing to sustain a society. It's great to be in an area where farmers take pride in their product enough that they'll label it organic. It's how we manage this ecology that determines everything else that society does. You can't do just one thing without changing the interaction of all 4 points on that diamond. And so we're not dealing with silver bullets or Stinger missiles that you may see in the magazine ads for the biotechnology or for these other products. We're dealing with an ecology and managing it to support the plant and to make it as least conducive for the pests, and it's all done through nutrition. All of those interactions have a tie back to nutrition. Nutrients are part of the plant, part of what we're growing, but they're also the regulators of physiological processes. I've likened those regulatory functions to a key and a motor. You have all the enzymes in the plant that function and can do a lot of work for you, kind of like that motor in your car. It can get you up to 60 in a few seconds. It can do a lot of work for you, but it doesn't do any work until you turn the key on. The micronutrients and some of the macronutrients are the keys, the cofactors, as we call them scientifically, that turn the key on for these enzyme motors that do the work in the plant and in the system. If we want to turn a physiological function off, we pull the key out of the ignition. We do that in agriculture and other areas for pest control with chemicals that we call chelators. A chelator is just simply a chemical that can grab onto an element and immobilize it or change its physical characteristics for physiological processes. So we have chelators then as ways to remove those keys from these physiological processes to shut them down. All of our herbicides and many of our antibiotics and pesticides are just simply chelators. They pull the key out of the ignition of a physiological process so that it can't run. Again, every herbicide is a chelator. You have to, if you gain that concept, you really understand what's happening in our soil sickness, in our crop sickness, in our animal sickness, and in our human diseases. What we've changed is the availability of those nutrients. We have predominantly one herbicide used throughout the world now, and that's Roundup or glyphosate, Roundup-like herbicides. It has multitude of functions because it chelates any positively charged ion. Glyphosate was first patented as a chelator, 1964 by Stauffer Chemical Company. Jim Chang invented it as a chelator to clean boilers and pipes. Grabs onto the calcium, magnesium, iron, and other minerals, and it makes it possible to remove them to descale those boilers. Patented in 1974 then as an herbicide by Monsanto, broad spectrum, kills everything. Great tool if you wanted to sterilize everything from a plant perspective. It was patented in 2010 as a very powerful broad-spectrum antibiotic. We talk about the 29 million pounds of streptomycin, penicillin, and tetracycline and the other antibiotics, and that everybody gets worried about antibiotic resistance. We're using those for specific pathogen suppression usually. Nobody says anything about the 330 million pounds of this very broad-spectrum antibiotic that is toxic to all of our beneficial organisms that we rely on for life. It's a very persistent chemical. very difficult to degrade. A half-life can be as long as 22 years, maybe as short as 9 months. Monsanto has lost 2 significant lawsuits where they were accused of fraudulent advertising for claiming safety, biodegradability, and environmental benefit. They lost all of them, all in all 3 cases. So that because it can be biodegraded, but it's not a predictable entity because it's primarily through co-metabolism rather than as a nutrient source. It's an organic phosphate. It's a growth regulator. Again, when you have such broad spectrum chelation, or the ability to immobilize so many critical nutrient elements, make them less available, you're going to change all 4 points on that diamond that we're managing when we're farming. It's not just a silver bullet. You're changing the entire spectrum of the ecology that we live in, that we rely on. We were told, and the EPA was told, that it's specific to the EPSPS enzyme. That's an enzyme that animals and humans don't have, so they told the EPA that there's no need to do any safety tests on this because it can never be toxic to us. Glyphosate inhibits 291 enzymes. EPSPS enzyme is down here about halfway in that 291. I don't have them all in here, but you can see there are some other very critical enzymes that are impacted that we do rely on. You say, well, if we don't have the EPSPS enzyme, where do we get our aromatic amino acids? Tryptophan, phenylalanine, tyrosine. Those are critical for us. Those come from the microbiome, from those microorganisms that are in our GI tract, our stomach, and our intestines and colon. Glyphosate is extremely toxic to those organisms, and as I'll show you, all of those gastrointestinal diseases that we're struggling with right now have a tie directly back to an impact of glyphosate in the GMO crops. It's not specific for just the EPSPS enzyme. It's essentially a very broad spectrum chelator and inhibitor. This is a schemate pathway. You can look at that, and I've just put in some of those mineral elements that are the keys to those particular enzymes. You can see that it's not just EPSPS. There are many places in this pathway that glyphosate is shutting down. True, if you shut it down up the top, you have a domino effect on the rest of them. But it's shutting those down also. A very powerful enzyme inhibitor that's involved here. Can build up in the soil. It's persistent. We have up to 19 to 20 pounds of residual glyphosate in our soils in our almond groves in California. We have it the same thing in citrus. We have it in our agricultural soils. It's detoxified fairly readily as it chelates with the calcium and magnesium and iron and other cations in the soil, so that it's not an active product because it's already chelated once it reacts with those particular minerals. However, when you go out with a phosphite fungicide or with your phosphate fertilizer for your crop, you can desorb that residual glyphosate and then have tremendous impact on that subsequent crop 10 or 15 years later, as we're finding in many of our soils that are essentially struggling to maintain an economic crop. You can see that the more phosphate fertilizer you put on, the more glyphosate is released. And then the power of that glyphosate in inhibiting the uptake and translocation of those essential critical elements then for the plant. Now, phosphate is a negative ion, but you see the competition because glyphosate is a phosphite. that competes with the phosphates so that you get a blanket reduction in nutrient availability. Farmers repeatedly tell me their crops aren't as vigorous as they used to be. Can't understand what it is. The agronomists will go out and look at their fields and they say, well, it was a cold spring or it was a dry spring or too much residue on the surface. They never connect the dots with the impact of glyphosate on a long-term basis. It doesn't take very much, 11 grams per acre, half an ounce, will inhibit the uptake of iron 50%, manganese 80%, and then you see the translocation of iron, manganese, and zinc, all inhibited at rates that are well below what we would consider a normal drift rate in agricultural practice. Glyphosate, Roundup's been a very powerful tool for weed control. Been the most abused chemical that we've ever had, the most extensively used. It's systemic, so that you just put it on one part of the plant and it distributes itself. It accumulates in the root tips, the shoot tips, and the reproductive structures in your legume nodules. Toxic to the organisms that might be in those nodules, your rhizobium, bradyrhizobium, so that as it's translocated, it moves down into the root system, moves then out into the soil through the root exudates, or about 20% of it moves out, 80% stays in the plant for as long as the plant's there. As it moves out in the soil, you're treating all of that area that is in contact with the roots. Much of that area for alfalfa or even wheat that can have roots going down 20 feet is well below any opportunity for degradation by microorganisms. We have a prolonged and extensive contamination of our soils. As it moves out into the soil, it's toxic to those organisms that would normally control our soil-borne pathogens, so that you increase susceptibility of the plant by reducing mineral uptake and also the natural biological controls that we've relied on for years to suppress some of these very serious pathogens. It stimulates the pathogens. But those organisms that we rely on for much of our nutrient availability, for biological control of our diseases, are all suppressed. So you change the biology. There aren't any voids in nature. You merely change the occupiers. And the pathogens then come in and occupy that void that is provided when the glyphosate or the Roundup takes out the other organisms, as you can see from this research of Zobiola and Kremer and others, so that you can see that even on a Roundup-ready plant, soybean plant here, you have a 500% increase in root infection by fusarium. What's the cause of sudden death syndrome? Fusarium glycines. Why did it happen? Because we've taken out the pseudomonads and the bacillus and the other organisms that used to suppress that particular pathogen. You can see those organisms that make manganese and iron available, very sensitive. And your hormone producers that increase root nodulation of your symbionts has a dramatic effect. It also affects those organisms that are responsible for soil aggregation so that the soil can store the water that we need later on in the season for plant growth. This is a 6-year study, organic versus conventional. This was Dan Olson's research in Wisconsin. This picture is after just an inch of rain, and you can see where the water was all puddling and starting to run off the field. We should be able to store 18 inches of water in most of those soils. You're having problems even getting an inch into the soil with our long-term GMO program with Roundup Ready crops and the glyphosate applied. You can't kill a plant with glyphosate in sterile soil. You stunt it. It's a growth regulator. That's secondary metabolism. What it really kills the plant are those soil-borne organisms that are present in all of our soils: Fusarium, Rhizoctonia, Pythium, Phytophthora, Glucosamines, Cornospora. Those organisms that we always have to deal with on all of our crops are stimulated, and when you remove the defense system of the plant, then they readily colonize, and in 4 to 6 hours you'll have Phytophthora and Pythium in those bean plants, where it might take 3 to 4 days to get epidermal colonization alone without that. You give the plant a bad case of AIDS. It's not limited just to the weeds as far as the overall impact, as I showed you with the root colonization with Fusarium. When you have the genetic engineering, you're merely inserting a gene or a genetic component that it provides an alternative pathway that isn't inhibited by pulling manganese as a key out of that shikimic pathway. What you have is another mineral that is readily available and not affected as much by the glyphosate. But it's the increased susceptibility to disease that is your herbicidal mode of action for glyphosate. Consequently, we have over 40 diseases that we now consider on the Threat Pathogens Committee as re-emerging diseases. These are diseases that used to be controlled relatively well by our common management program. They no longer respond to that. We have serious economic losses. We're concerned about new strains and all the other explanations, when it's really just that predisposition that the Roundup-type herbicides provide for us. You can see that if you look at the top Roundup-ready soybeans up there, you can see that center inoculated pot. That's a little more than root nibbling, and that pathogen would cause some economic loss. But if you put a little bit of glyphosate on those leaves of those Roundup-ready soybeans, and as it moves down, then you see tremendous root rot, and I've seen economic damage there of up to 40 bushel loss with this pathogen that used to be considered only a root nibbler. This is a field at the Purdue Agronomy Farm. This is a field that's been in the same crop rotation, the same crop sequence, same fertility, same tillage, same soil, same weather for 30 years. It's not supposed to do this. It's split right down the middle here. You see a very severe take-all. If you shell out those ears, you don't get those plump kernels that Bob was proud to comment on. What you get is a bunch of shriveled kernels and a bunch of chaff, because the roots and the crown are all black from the Glucosamines, from the take-all fungus. You look over here, the take-all fungus is there, Glucosamines here, but it's working just as a root nibbler. The only difference on here was all Roundup-ready soybeans the previous year. The only difference is that on this side of the field, here from this flag, if you can see it back there, on to the left, our station superintendent sent his crew out and said, spray this late because it's got some late weeds that came up in it. He had to be able to sit next to his neighbors in church, apparently, so that he wouldn't be considered a heretic by having those few weeds there. But this side didn't get sprayed. And the difference is essentially the difference between a profitable crop and essentially an unmarketable crop, because the entire biology has been changed. You can see the same thing here with soybeans. You see on this side, this was in alfalfa the previous 3 or 4 years. This had been in sweet corn the previous 3 or 4 years. They want to take the alfalfa out and marry the field as one field. Put out 2 quarts of glyphosate, Roundup, to kill the alfalfa the previous fall. This was sweet corn, so it didn't have any glyphosate on it. And then planted it all to Roundup Ready soybeans this particular year. You can see right to the line where the sudden death syndrome is setting in. And a week later, this side over here where the glyphosate had been applied the previous fall, you can see it was all defoliated, essentially terminal in its further growth. Slide up here is with Goss's wilt on corn. You can see the GMO and the non-GMO. Just an application of glyphosate eliminates 6 genetic characteristics for resistance to this particular bacterial disease that hadn't spread from a few counties in eastern Nebraska and western Iowa for 30 years of recognizing the disease. You see the effect here because in the genetically engineered hybrids, they sacrificed resistance to start with in order to get expression of the genetic traits that they were trying to market. The other thing is then when they apply the glyphosate and those powerful adjuvants with it, that it nullifies the other resistance characteristics. In 2011, this disease, which was essentially a non-economic disease prior to 1996, this disease in 2011 cost us 1 billion bushel of corn in the Midwest. Jack, now you have an idea of why we get this kind of spiking. All you have to have is a little favorable weather, and we've got a disaster. You can look at the other situations. Dr. Miriam Fernandez in Canada has shown that if you apply 1 application of glyphosate to your wheat or barley ground as a burn down, any time in the previous 3 years you can anticipate a significant increase in Fusarium head scab, Fusarium root rot, and the toxins that those Fusarium species produce. If you're doing it every year, about a 300% increase, and if you're following Roundup Ready canola where your glyphosate Roundup usage is even higher, your disease severity and especially your toxin production is increased immeasurably. We have Roundup Ready sugar beets. Put this in. I know you don't grow sugar beets in New Zealand, but just as an example, before Roundup Ready sugar beets were released, the people at the USDA Fort Collins Sugar Beet Laboratory published their results, and they said you have to be really careful if you're going to put glyphosate out on Roundup Ready sugar beets if you have any of the crown rots present. It's interesting that the senior author on that paper went to work for one of the biotech companies and now is a major proponent for genetically engineered sugar beets. But you can see what's happened now. We've had them 3 years in the valley. You see this sugar beet pile here. 200,000 ton of rotting sugar beets because that precaution wasn't heeded. You can see what those beets look like up close. They look more like fuzzy little puffballs than they do sugar beets. They estimate $6 million worth of loss to the farmers. This is a co-op. All comes back to the farmer because when he signs the seed agreement, the technology agreement, to use that seed, he waives any current or future liability for the use of that seed. the company scot-free. It's all borne by the grower. You say, well, we have genetic engineering. Doesn't it protect us from the effects of the Roundup? Again, there's nothing in that technology that does anything to the glyphosate that's applied. Still a very powerful chelator. If you really want to understand what the technology does, you have to realize that it's more like a virus infection than a breeding program. The whole concept is based on fossil science of one gene, one trait. We know that's not true. We had to throw it out 35 years ago. You have one gene that's in relationship to the spatial relationship to other genetic materials in the environment that influences the end product. There are hundreds of other products that are being produced. There's nothing in that genetic engineering that does anything to the product, the herbicide, that it's engineered to tolerate. That's why it accumulates. That's why it persists. Every genetically engineered plant that I know of, when compared with its isogenic parent, causes a yield drag. That's not the way to produce more for a growing world population. Our economist said, why in the world would farmers sacrifice 6 to 12% yield just to simplify weed control? You had a very powerful tool for a few years till we had resistant weeds. Now we're paying the consequences, as Bob showed with that combine sitting out there with a giant ragweed resistant to Roundup. And you realize that's why we have GPS units on our combines, so we can find the crop. Glyphosate's there for the life of the plant. It's there in the food that you're eating, and what you're feeding to your animals is a very strong mineral immobilizer, an antibiotic. You see that reduced efficiency in those minerals impacted in the physiology. This is Roundup Ready soybeans. You'd anticipate a little lower lignin content because that comes through the shikimate pathway. We're growing that crop for its nutritional value. Look at the reduction in amino acids. You look at the reduction in photosynthetic efficiency. We're growing that crop to capture the sun's energy and to combine that, or use that to combine the carbon dioxide and the hydrogen from the water and store that sun's energy as sugar. Combine it with a little bit of free nitrogen from the atmosphere if we haven't killed off our nodulating organisms, and then we can have the protein. But there's another universal characteristic that goes along with genetic engineering. That's that it takes twice as much water to produce a kilogram of dry matter in a Roundup Ready plant treated with glyphosate compared to one that isn't. For my neighbors, where they spend $100 an acre in electricity to pump their irrigation water, it means it's going to cost them $200. California, they don't have the water regardless of what the cost is. So they're down to about a 4-foot or a 6-foot square trying to maintain almond production. Water's a scarce commodity, becoming scarcer. You always have those cycles, and you say, well, does it matter in the Midwest, where we get 40, 50 inches of rain a year? Well, in 2012, we went 6 weeks without any rain in a lot of areas. And you can see the Roundup Ready soybeans over here compared to the non-Roundup Ready. Yeah, non-Roundup Ready have to have water too, but the efficiency of that water makes a tremendous difference yield-wise, not just for soybeans but for corn. These two fields separated by a 60-foot gravel road. You can see the drought stress. One of the typical characteristics of GMO, again, is a smaller root system. When you disturb the integrity of the genetic code, reduced nutrient efficiency, and smaller root system, and increased drought stress are just characteristics that come along as part of that yield drag. You have two factors that you need to deal with in genetic engineering for herbicide resistance or for insect pesticide production. You have the effect of just the disruption of the integrity of the genetic code, and you see that here with a 17% reduction with this particular soybean variety, down for manganese, and about a 47% reduction in zinc. And then when you put the glyphosate out, you see all of the other impacts then as it just hammers away at a system that's already been hammered on. And you see that both in the vegetative growth of the plant. Look at your magnesium, part of that chlorophyll molecule, very critical element for your animals and for us, for grass tetany and all of those problems and systems. Look at your manganese to split the water for photosystem 2. And you can look at all the others, not just in the grain and the harvested product, but during production. So that you look at those aspects, and in some areas we recognize that with high pH soils that we have Lyme-induced chlorosis, iron deficiency, just from the environmental characteristics of the soil. In Wisconsin, they've developed some seed treatments with some iron, brought them from 33 bushel up to 56 bushel, so that looked very good, and they were pretty happy with that for $2.5 or $3 an acre, pretty good return on your investment. When they put glyphosate out, they went from 33 bushel to 8 bushel because it chelates iron, reduces its availability, even in the Roundup Ready plants. These are Roundup Ready soybeans. They added the seed treatment, got them up to 19 bushels, still a long way from 33. That's because they didn't recognize that it's a broad spectrum chelator, not just involved with iron. My research would indicate if that also applied manganese, that have probably seen at least a 56 bushel, or maybe even a 65 or 70, because they probably didn't recognize the hidden hunger that was already present under those high pH soils. Resistant weeds have already been mentioned, nullifying the benefit in many of these areas for the crop. They're still paying $25, $35, up to $125 an acre tech fee for them, and still having to use all of the other herbicides for their effective weed control. There are other things that are much more important, and that's that the purpose for growing our crops is to provide the food and the feed that we need to sustain society. And you can see all of the impact that the modern technology, quote unquote, has brought to us from the reduced nutrient density, as you see here, not just in manganese and magnesium, few of those, but you see it across the broad spectrum. This is alfalfa and soybeans. We could do it for corn. We can do it for the other crops. And you say, well, does it make a difference? Dr. Jeffrey Shepard at the University of Wisconsin, or Minnesota, veterinary pathology, did a 5-year study trying to explain why they were having such a high incidence of miscarriage in their animals, why they were having such a high rate of deformities. And his conclusion after that 5-year study was that they were extremely deficient in manganese. All of those that were stillborn were way below any sufficiency level, and 63% of those that weren't stillborn were still way below the sufficiency level for manganese. 80% of the livers in our commercial slaughterhouses I've been told by one of our veterinarians, has to be discarded because it's in such terrible shape with no manganese and no vitamin B12 cobalt to support those liver functions, that it's not fit for use and has to be discarded now because we've reduced the nutrient density in our feed and our food products. It's a study of Carmen and Vlieger looking at the allergenicity and other effects of GMO versus non-GMO. It's the next to the longest study of this type, other than Dr. Cirolini's study on the mice for 2 years. This is a 5-month study from weaning to marketing. You can see the allergenetic effect of that irritation that comes from the GMO proteins in the corn and soybeans. If you look closely, you'll see the small ulcerations. You get into the intestinal tract, and you see the deterioration of the walls, the large ulceration that takes place, and the leaky gut, the opportunity then for the celiac or for the gluten intolerances that goes right into the bloodstream because those normal barriers are no longer there. The organisms that we would normally populate our GI tract with are sensitive to glyphosate, and they've been removed so that we don't have that opportunity for protection. They're also responsible, those organisms responsible for our immunity, so that it changes the whole environment. Animals can tell the difference. These are 2 bags. These are isogenic, triple stack, and the normal parent. Got left at the back of the warehouse. Gilbert Hostetler, the corn breeder, said, wonder if the mice are trying to tell me something that I ought to know. Well, if you look up here, these are, again, the triple stack, and it's isogenic parent over here that stayed up in the tree for 9 months. Squirrels could tell the difference. Had a farmer in Florida that grows sweet corn and says he sends it up to the Yankees up north all winter. Said it's Roundup Ready sweet corn's the greatest thing that he's ever seen. I asked him what made it so great. He said he's been growing sweet corn for 35, 36 years. Said it's the first time that he's ever grown sweet corn that the raccoons wouldn't eat near. Now, if you'll break one of those triple stack ears right about harvest, you'll smell the formaldehyde. That's probably one of the ways that the animals can tell the difference. We can't smell it once it's sat for a little while. At least I can't. But the animals can tell the difference, and they'll avoid a GMO crop if they have any choice. 2002, our United Stock Growers of America Association gave testimony before Congress that there were 2 conditions threatening the survival of the industries. One of them is premature aging. The second one is reproductive failure, with as many as 40 to 50% of their pregnancies being lost in both cattle and dairy, and we see about a 30% to 40% reduction in litter size and litter weight in our hog production. It's a serious problem. When you look at that, this is a study in Iowa, GMO versus non-GMO. You can see the premature aging. You take a prime beef to market, and we're marketing them now 2 or 3 months before we used to, because if we don't, they're not healthy enough to stand that extra 2 or 3 months waiting time, and we end up with a high percentage of downer cattle, and they lose it. So we're marketing earlier to compensate for the poor health of our animals. And you can see the allergy response here in the GMO fed compared to the non-GMO and that tallow color. It's a study, 2011, Hordes Dairymen, 2 veterinarians surveyed dairies from Mexico through Canada. Said, why are so many cows losing their pregnancies? They said, 20% is too much. We have a dairy not too far from us, 70% pregnant or miscarriage. You don't stay in business very long. Bankruptcy is the alternative. If they have the land, they become crop growers and abandon the animal production because too many pregnancies are lost. You look at the number of services. You look at the percent of the herd that's pregnant now, or the number of animals that are now open that were at one time pregnant. Had a doctor at one of our medical schools comment, one of the veterinarians that we work with, and said that it's not unusual for a woman now to have 4 and 5 miscarriages before she has a live birth. That's not normal. What's changed? GMO and glyphosate and the other pesticides have changed. This is that study of Jeffrey Shepard's with the calves. You can see the deformity, the underbite. You see the typical arthritic type condition in the joints. You have to have manganese in order to move calcium into the bone structure. And then you look at the concentration or the content of manganese in the feed that they're getting. This is below what those plants would even need to start photosynthesis, but this is what used to be average. Now it's the maximum they can find. We've greatly affected that production capability and the nutrient density of our feed and our foods. It's a very powerful antibiotic. Study of Shihata and Clare and others that have all published on this, Dr. Monica Kruger. All of these beneficial organisms that are responsible for nutrient availability are all sensitive to glyphosate. Again, there aren't any voids in nature. When you take one group out, another group comes in. All of these pathogens are 4,000 plus times more insensitive to glyphosate than the beneficial ones. Even though on Monsanto's patent they include those as being organisms that are sensitive, it takes over 4,000 times the concentration to do that. So that you see we've changed the health and safety of all of our crops. Research of Dr. Monica Kruger has shown that when you take 1/10 of a part per million of the glyphosate in the feed, you eliminate the Enterococcus faecalis and faecium, and a normal ruminant like you'd have here that completely suppress your Clostridium botulinum and that powerful bot neurotoxin that we worry about in biological warfare. And you suppress that so that your Clostridium botulinum takes off, and it's a matter of just a year, sometimes a few months. And that cow will develop chronic botulism and succumb to this disease. Sudden infant death syndrome is caused by chronic botulism. It's the same problem. If a baby hasn't developed that natural lactobacillus and bifidobacteria and enterococcus in its GI tract, it's very susceptible then to the Clostridium that is found in dust and dirt and food and other factors, or if it's wiped out because of the 119 parts per million glyphosate that's found in some of the baby food. It's not ever going to have an opportunity for developing resistance to any of these pathogens or even to developing the antibodies that are required with the immunization program that we impose on them. 50% of our bees have been lost from colony collapse disorder. 3 factors that are characteristics here. You've got bees that are micronutrient deficient. You have bees that no longer contain the lactobacillus and bifidobacteria in the stomach, so that they can't digest their food and they don't have the immunity then to the varroa mites or to the nosema or to European foul brood or the viruses. So that Then when they go out for foraging, you find the same problem that you find with the neonics, and that you have that very powerful glyphosate inhibition of the endocrine hormone system. So that all three of these factors, and then with the synergy with the neonics, our bees are really having a tough time. Our almond growers were spending $2,000 a hive and shipping them 2,600 miles in order to get pollination of the almond crop, because 95% has to come from bees. You see that effect when those bees are harvesting nectar from non-GMO. You see in the honey crop, the stomach, it's very fluid, it's being digested then by those bacteria. In the non-GMO, or in the GMO over here, those bacteria aren't present. So that what you see then is the agglutination of that material that can't be digested. And the tissue then in the GMO starts to die compared to what you have with the normal. These are the levels that the EPA has approved for our various food crops. You have to ask the question, why is glyphosate twice as toxic in canola oil than it is in refined soybean oil? You can have twice as much in refined soybean oil as you have in canola oil. And you can look at the other. And then you realize that's not based on science and toxicology. That's based on what we're finding in the crops. And they say we have to raise the tolerance levels so we can have, quote, unquote, safe crops. You can see those levels. You can see what the dietary risk assessment from Dr. Charles Benbrook looks like, where he took the USDA figures for glyphosate in soybean, calculates then what your dietary risk is for all of the pesticides. He's done this for years. You can see that the dietary risk index for soybeans and AMPA is 82.7. The nearest to it are the neonics, 14.9. All other pesticides combined are less than 1. You see what our exposure level is to this very powerful mineral chelator, an antibiotic. And then you see the tragedy that we have at Yakima. Same thing in parts of Florida, other parts of the country. It's just that it was publicized for a short period of time in Yakima, where they were dumping the water, or dumping the rodeo in the water, provided their drinking water and their irrigation water. And you can see a year after they started dumping that in for invasive weed control, what the personal tragedy is. So you look at the impact here for a number of diseases. This is celiac in children. You can see the introduction of the GMO canola. This is the glyphosate that's found in the canola, and this is the incidence of celiac requiring hospitalization in the children, and that same curve fits all of these diseases. There's no other factor that matches that same epidemiological pattern for diabetes, for autism, for any of these diseases that are now reaching pandemic proportions in our society. And you see all of those situations and the personal tragedies. I work in Guatemala periodically, consult on sugarcane, bananas, and some other crops. 1/4 of the sugarcane workers in El Salvador across the border from where I work are now dying from end-stage kidney failure. 25% of the male population in the 2 states that grow sugarcane. You can see the other impact, all related to glyphosate used as a ripener. In 1970, 1 in 10,000 children was born autistic. In 2070, it was 1 in 150. In 2009, it was 1 in 100, 1% of our children. 2013, it was 1 in 50. In 10 years, it's predicted to be 1 in 2. Now, those are personal tragedies. That's not accident. From 1 in 10,000 to 1 in 2. And you can follow that curve with the glyphosate and the GMO crops directly with the personal tragedies that come to families, to communities, to our society with any of those diseases. And so in summarizing, I would kind of pull it together and just state that future historians may well look back upon our time and write not about how many pounds of pesticides we did or didn't apply, but how willing we are to sacrifice our children and jeopardize future generations for this massive experiment that's based on flawed science and failed promises, just to benefit the bottom line of a commercial enterprise. Thank you for your hospitality and for the opportunity